Hello everyone, myself Ankit Shivare. Today we are going to have a session on LT Spice. So this is our first tutorial. In this tutorial we are going to see the different options that are available in LT Spice, the tools control panel options. Then we are going to see what are the different windows that are available in LT Spice. Then we will go to the tutorial. First we are going to think on voltage divider. So let us have a voltage divider circuit and see the waveforms, how it looks. Then how to set up the different window panes, etc. That all things we will see. Okay, so first we need to install LT Spice X511 as per the tutorial, as per the link I have sent you. Okay, so you try to install it. If you face any issues, then revert back. So what are the different options that are there? Files, you can see there is no schematic, so you can have a new schematic. So a window like this will open up, right? Then you can have save options, etc. Then this is spice directive, capacitor, inductor, diode, and all these things will be there. So we will see how all this we can use. There's a new symbol, view. There are spice netlist option and all these things. So first, the important thing is the color preference. How you want to set up the color preferences. So like for background, suppose I want a white background. So how will I do that? So you can see when I do this, so this is now a white background. It looks better to me. So I will set a white background for this. So for all the other things I can set up. So I can, for grid I can do this. So this will be a black dots that is coming up. Probably in the video you will not be able to see, but this is the black dots that will come up. Now first we need to save in LT Spice simulation. So first tutorial I have saved in tutorial 1. So I can save it as back as tutorial 1. So do you want to replace it? Yes, I said. And I can close this one. Yeah, so this is how I can save the tutorials. Now in tools control panels there are a lot of options. Color preference I have told you. Color preference control panels, you can see that these are the compression that will occur. Okay, absolute or voltage tolerance, current tolerance. We will have a discussion on this. It's means how much error you can tolerate actually in your simulations. So you cannot take it arbitrary also, and you cannot take it very low value also. It's so you have to see that which simulation is good. So these are the integration methods. So that spice simulation will occur by these numerical integration methods. So this is trapezoidal, modified, trap, clear. 3 methods are available. There are more options available with the higher, with the like cadence, spectre. Lot of options are available, right? These are the G min, absolute tolerance, relative tolerance, CHG tolerance, TR tolerance. All these tolerance we will discuss later. Okay, so let us start with this, and we will have a discussion on this further. So first we will need to draw a voltage divider. So for that we need 2 resistances and a voltage source, correct? So let us have a voltage source. We have go to the component section and you go to the voltage option. Okay, so you place here. Then you need 2 resistance as well. So you need a resistor. So you can have this. So now you can have 2 keys. There is control R and control K. Control R is for rotation and control K is for mirror. Okay. So control R we can do like this. So this is the 2 resistance you can draw. So these are the 2 resistance I have drawn. So always we need a ground for all these things. So we can have this ground and connect here. So space bar is fit the screen. Now we can draw the wires and connect all the components. So a closed loop is formed. Okay. Now we need to set the values of this voltage source. So let us see what will happen. So right click on this and you will get these options like DC value. So let us assume that we are putting a 5 volt DC value, and what is the series resistance? So let us say we are not putting anything, right? So okay, I said. So this is the V1 and this is the 5. Okay. Similarly, we can set the resistance values. So tolerance is there, power rating is there, like how much power you want to have. So let us set up a simple 10 ohms and 10 ohms, 2 resistances. and this is how your circuit will look finally. Now we need to do the simulation of that, so we need to set up the operating point. So spice directive will come, so we can say that we need to have a DC operating point, so we put .op and we just place it here in this window. So the spice will understand now here that operating point needs to be calculated, .op. Okay. Now we need to simulate the simulation. So when we run here, so see a window will pop up. So these are the different nets that will show. So like this VN001. So we don't know exactly what is VN001, but we can think like this is the voltage source. So this must be VN001, right? So this is 5 volts. So it is naming this net as N001. And this is N002, that is 2.5 volt, because 10 ohms, 10 ohms, so voltage is splitted, so it will be 2.5 volts. So this is voltage N002. Now these are the currents, because you can see in the window option I have saved all the device currents, so it is saving all the currents. So IR2, that is 0.25 ampere. So 5 divided by 20 ohms, so that is what, 0.25, right? So this much current is flowing. Now you can see that a current is shown negative here as well. So what does this signify? Is the current always it sees from the positive to the negative. So means current is always from the positive to the negative in spice simulations. So here current is going from the positive to the negative end. So inside this current is going from positive to negative, but means it should be like this way. If this is positive, this is negative, so it should be emitted. So that's why it will be positive. If suppose I place voltage source here and the resistance here, then the current will be just opposite. So we can do that thing. So let us do that. So I just cut up this net, this net, this net, this net, and just sweep it. So we can move that. So this is the move option. So you can just place it here. You can move this voltage source to here. Okay, so it is little bit far, so let us hit it here. Okay, and we need to again cut it. Cut these nets, floating nets, and connect it back wires. So let us see what happens. So let us go to the spacebar fit, and I now go to the spice netlist. We can see the spice netlist. So this is the spice netlist. So this is V1 voltage source between two nets N002 and 0, that is ground, and that voltage is 5 volt. R1 resistance between nets N002 and 001, the value is 10 ohms. Similarly, R2 resistance N001 and 0, the value is 10 ohms. We are calculating the operating point, so .op, and always the spice netlist ends with dot end. Okay. So now again we can run the simulation. Yeah. So now you see the current has changed to positive in the resistance values, because the current was swinging from the positive to the negative side, right? So this was now the current is going in this direction. Okay. So hope it makes some sense, right? And the voltage current through the voltage source is negative now. Okay. Okay. So this is how it goes. We will have next session, and there we will see voltage control voltage source. Thank you.